Good afternoon, everybody, or good evening. I mean, it's 5 o'clock somewhere. Apparently, it's 5 o'clock here. So we're doing this last session of the day. Super happy to be here. So I'm Fred Balsiger. I work on the Windows Silicon and System Integration team here at Microsoft. My team spends a lot of time thinking about running AI models from cloud to edge. And specifically, when I talk about the edge, we focus on Windows AI models offloaded by the neural processing unit. And so with that said, our favorite platform is obviously the Qualcomm 8CX Gen 3 compute platform. So now you probably know why I'm here. So I would like to introduce you all to my good friend at Qualcomm Technologies, Vinesh, to talk with you about all this kind of tech, the AI stack, of course.
Thank you, Fred.
Absolutely, thanks.
Okay. See a lot of familiar faces in the audience and hopefully online. For folks who don't know me, I'm Vinesh Sukumar. I lead the AI product team at Qualcomm, where I have the opportunity and privilege to think blue sky, and obviously working with my research and engineering teams translate that into reality. So the topic of today's discussion or presentation, I should say, is Qualcomm AI Stack. How are we actually opening it up for developers, and how do we really drive scale across multiple platforms, and what is the connectivity from edge all the way to cloud? So that being said, any given AI conversation these days cannot skip generative AI. We've got to start with that, right? But a quick funny story. These days, even my 6-year-old daughter talks about llama, vicuna, alpaca, all the animals in the zoo, on large language models. It's so surprising that she's so informed about generative AI. Then you have the other extreme. My 65-year-old mom, she's now hooked on to creating these unique images. I kind of got her exposed to running Snapdragon, running the Stable Diffusion on a Snapdragon device. And she creates all these fantastic images with 120 characters in the front and side. Though it's annoying in sometimes because she keeps texting me all these images, I had to pick a few to kind of put this slide together. But it's makes me happy that AI is once again relevant, right, because of generative AI, and to a large extent, satisfies or applies to multiple age groups, and that's the most important thing. So that being said, we at Qualcomm strongly believe that inferencing is best served closest to the data that's collected, or rather what happens on the edge stays on the edge. Now, this is not to overlay the fact that cloud inferencing is not important. It is absolutely important, but this is going to supplement to what cloud infrastructure is already established. Why? Is because as we move towards generating these kind of modalities, either could be textual modality, language modality, or even images and output modality, it's quite important that you understand the context and then provide the image. And as such, we strongly believe this kind of contextual awareness or environmental awareness is only possible as you start getting more information about the user. A simple example would be my daughter keeps asking me questions about geography and literature, and I'm really bad at that. So I have to go work with some generative AI models to really help me understand in a much more easier way. If I ask a question, help me explain about George Washington, the physical output it creates, it needs to be equivalent to a 6-year-old, not like a 40-year-old guy, right? And that is only possible if you understand what the user wants, what age group, what is the emotional intelligence of the user, so you can tailor your output to that specific user. And I think that kind of foundational investment is possible as you start looking at on the edge kind of scenarios. So we strongly believe moving forward, the future of generative AI is running on the edge. Now, that being said, we demoed generative AI, which is basically looking at text to image kind of generation. And we exposed this to the audience, I would say, sometime in March of this year in Mobile World Congress. Historically, even before that, a lot of folks, I'm pretty sure developers around here, started playing with DALL-E that was exposed to OpenAI and fantastic images. I don't think there was a lot of awareness in the community that this is even possible on the edge. And we at Qualcomm were one of the first platforms to actually showcase this, that this is actually possible. So this is approximately 1 billion parameters in size. It creates a 512 by 512 image, and we showcase this to the audience. And the response we got was enormous. They were quite amazed with the fact that this is even possible on the edge for an extremely small envelope like 5 watts on device. And you could see, the PR activity it's created. It was just fantastic. Now, after that, there's been a lot of requests to say, hey, whatever we have done this on a mobile-based device, can I replicate exactly the same thing on a PC compute platform? And using a Qualcomm AI stack, working with our fantastic partners at Microsoft, we were able to demo this physically on device. It's actually running on an 8CX Gen 3 device. It's available on Qualcomm demos. If anybody's interested, please go look at it. Here we've actually taken a pre-recorded video wherein I have approximately 150 characters as my input text prompt to actually create a scenario wherein it looks at a representation of a harbor, and then kind of create an artistic version of that with a lot of boats around it. And it kind of comes back quite soon and quite fast. Now, our intention was to showcase that large language models or large vision models is completely doable by running this on our Hexagon AI engine that's fully exposed through a Qualcomm AI stack. Now we're going to look at performance optimization, those kind of stuff, which will continue to get enabled in the next couple of weeks/months. Now, before we deep dive a little bit more into Qualcomm AI stack or even the Hexagon architecture, I think I'll take the opportunity to educate my audience on how did the AI experiences or use cases actually evolve in a compute envelope, or I should say a compute platform. When you look at historically the trend around how was AI relevant in a PC platform, I think during pre-COVID timeframe, there's a lot of focus and attention on how to improve human-to-human interaction. How do I actually make video AI more relevant? How do I make audio AI more relevant? So that when you happen to have video conferencing, or even for casual or game streamers, it can be fully made sure it's much more presentable to them. So there was a lot of investment around, I would say, image quality enhancements, background blur, speaker identification, transcription, translation, those kind of stuff. And they continue to be relevant because these days you can see Teams being used exhaustively, and we take the privilege of already enabling them and enhancing them on the edge. But with time, we have also, again, working with our partners at Microsoft, started to use the investments in AI and expand this beyond your traditional use cases of human-to-human interactions to productivity. How can I actually use this on gaming environment kind of scenarios? So if I look at that, the graph I have here, the x-axis kind of reflects the model size, and the y-axis kind of showcases how the use cases have morphed with time. And to a large extent, the Windows Studios effects have had a continuous upgrade in terms of feature enhancements. And with time, the physical size of these models have grown. They used to be, give or take, about 100 kilobytes, and now they're going to be a much more significant model of enablement in megabytes kind of range, only because you now have much more concurrent features, all executed as a single graph, and becomes much more relevant there. We have started looking at enabling a lot of enhancements on game super resolution, pushing towards 2K or a 4K, so that when you happen to have a game streamer, he wants to enhance details or spatial details within a capture. This is completely doable using our Qualcomm AI stack on the Hexagon engine. On the right-hand side is where we truly believe you're going to see the next evolution of AI 2.0, as I call it, in compute platforms, wherein you're going to be focusing a lot more towards a generative and predictive AI. How can I actually start using large language models or large vision models and integrate them into apps that are already popular within the Microsoft 365 environment? You've seen a lot of talk on Copilot. How can we actually put those intelligence into Copilots? Can the Qualcomm AI stack actually accelerate this on the edge? And all of that is completely possible. So we believe moving forward, you're going to see a lot more applications, the use cases around text to image, image to image, text to text kind of scenarios, which actually will push more towards productivity and content creation for any common user or or an application developer. Now that being said, on what kind of use cases, it becomes relevant to also kind of give you a quick history on Qualcomm's AI engine. In the previous slide, we talked about plenty of use cases, how these use cases have actually evolved with time. But when you look at these use cases, they have quite a different key performance indicator or key experience indicator. What I mean by saying that is some of these use cases are very latency sensitive. Some of these use cases are very bandwidth sensitive. Some of them rely on quality of service. So you can't actually use the same underlying hardware to satisfy these use cases. So we actually provide the flexibility to our developer community and ecosystem partners to say that depending upon the type of KPIs that they have, they can actually run some of these use cases on Kairos CPU, especially if it involves first inference latency or anything to do with being sensitive to latency. You can absolutely push that. We have the compute investments there to really drive that, usually small compute workloads. If you're looking at use cases that are mostly gaming-centric, we're looking at ray tracing, acceleration. We're looking at content creation kind of scenarios. You drive most of these use cases on graphics. Now, majority of the use cases, to a large extent, when you look at a casual consumer, you want to make sure that power efficiency or the energy draw from the battery as minimal as possible. In those cases, which is mostly anchored on sustainability, we push towards our proprietary Hexagon processor, Hexagon AI engine. Here, you're going to see a lot of use cases in the previous slide that we talked about on human-to-human kind of interaction, game streaming applications. All of them run on our Hexagon engine because it gives you the highest power efficiency and performance at the lowest milliwatt draw. Now, last but not the least, we also have Sensing Hub. Why is that important? Now, you also want to have a lot of use cases which are in the bracket of always on. What does that mean? If you're looking at a scenario wherein you want to activate your device based off a keyword detect or a key phrase detect, you want to make sure that the amount of physical power consumption necessary to activate based off a phrase is as minimal as possible, usually in sub-milliwatt kind of range, single-digit milliwatt range. And that is doable using our Sensing Hub. And I'll kind of talk through some of the use cases so you kind of get a preview to where Sensing Hub gets actually utilized in a very PC-centric environment. Now, that being said, let's expand a little bit more on what our Hexagon AI engine actually does. In the previous slide, I kind of give you a quick introduction on the types of use cases, what kind of KPIs or what kind of KEIs we really focus on. But when you go one step lower in terms of use cases, these use cases are either very matrix heavy or scalar heavy or vector heavy, right? So in this case, you really want to make sure your physical Hexagon engine is broad enough to satisfy these kind of variables, and as such, we have made investments accordingly. Now, at the same time, as I mentioned before, our focus of attention is to also make sure the physical power consumption is as low as possible, and as such, the sustained battery draw or the energy draw from the battery is as minimal as possible, and that's only doable if you happen to have a large shared memory that really supports these kind of connectivity modules. Now, moving forward, as I described before on Qualcomm Sensing Hub, this is our ultra-low power AI engine. As I mentioned, supports multiple modalities. It can be utilized both for camera, for sensing, and for audio. And if you want to have a higher probability of success, it also supports sensor fusion, wherein you can actually take inputs from multiple sensors that's available on a compute platform and drive your conclusion based on that kind of investment. Now, this is a use case that is actually in production that we've launched on our Compute HCX platform, wherein you really want to look at scenarios wherein you want your PC device to get automatically activated based off your presence. You want the screen to be dimmed out by detecting a registered user on the device. You also want to make sure that if you're working on a very sensitive document or a very kind of a private kind of situation, and if somebody glances over your shoulder, then you want to make sure the screen automatically turns off, or rather privacy is fully protected. And if the user gets called upon and he kind of exits from his location, you also want the screen to be completely turned off. And all this is completely doable using our always-on vision kind of technology that we've enabled as part of our Qualcomm HCX Gen 3 platform. So this is one such scenario which kind of explains it. Here, you happen to have an always-on camera that's in the bezel. It detects the presence of a user. The screen gets activated. It gets logged on. And then, the moment the user is not paying attention to the physical screen, the screen automatically dims off, right? And when he sees his attention is back, and then the screen gets activated. And why is this important? Because it really preserves user privacy and also helps enable on power consumption utilized for these kind of use cases. Now, moving forward. Now, in the last couple of slides, we talked about use cases. We talked about a foundational investment that we have in our hardware. different kinds of hardware that are mapped to kinds of the different classes of experiences that we try to enable on. And now let's talk about benchmarks. In the ultra-competitive space of AI, there's always been a very general question on what is your performance? How can I gauge your performance? Is it good enough for most of the applications? So Qualcomm strongly believes that we make and publish our performance benchmarks quite public. Anyone is more than welcome to go look at it. We are a strong proponent of ML Commons. ML Commons is a very standard body out there wherein they have a certain certified set of tasks, and then anybody could go make these results. So what we have done is I've taken a snippet from ML Commons. This is a submission made in April of this year, wherein it looks like classification, detection, segmentation, and language understanding kind of use cases, which are quite prominent in the PC kind of industry. And you can see the numbers in terms on both in a battery mode and in a power state mode. And you can see the numbers that's available are pretty much off the charts. We can confidently say that we pretty much beat up any competition out there, and we strongly believe this investment can actually drive us to move towards complex use cases like generative AI on the edge. Okay, now that we've talked about performances, let's jump on to our Qualcomm AI stack. This is where the rubber meets the road. Now, for the very first time, we've actually created a unified AI software offering that combines all the previous AI capabilities and tools into one integrated solution. Now, this is important because it's a full development stack from top to bottom, supporting all the popular frameworks, which I'll explain a little bit more detail in the next couple of slides, and then provides you on also the flexibility to all the developers to program to metal if necessary. Now, this intention of developing one Qualcomm AI stack provides infrastructure for any developer out there is to develop once and deploy anywhere, so that you don't have to keep creating these binaries or blobs for multiple form factors. So this is our investment. So far, it's been quite widely accepted, and I want to do a quick introduction on how this really helps moving forward to all our ecosystem partners. So one step deeper. So when you look at our Qualcomm AI stack, it has got multiple layers of offering. When you look at any application developer who's really involved in AI, the very first thing he really looks at is how can I look at enabling a pre-trained model and translate that pre-trained model into a blob that is executable on any hardware IP of interest. So the very first step is on frameworks and runtimes. We support any kind of framework. In other words, we provide the flexibility for developers to bring pre-trained networks from any popular frameworks. Could be TensorFlow, could be PyTorch, could be Caffe, or even ONNX-based formats. So once you happen to have those pre-trained models, you can use our runtimes to actually create a physical binary or a blob that's executable towards a dedicated AI engines or even general purpose hardware like a CPU and graphics. Now on the runtimes, we have, I would say, two different sets of runtimes. One which is unique to Qualcomm, which we call as the Qualcomm Neural Processing SDK. Another one is for scalability, like ONNX runtime, TF Lite Micro for embedded devices, or even TF Lite, or even DirectML. And as such, if any application developer wants scalability across platforms, scalability across SoCs, or scalability across multiple generations of SoC, that is fully doable using the infrastructure that we have as part of runtimes. Now, moving one step lower in terms of developer libraries and services. Now, this is, again, a big bucket that contains a lot of investment, especially around libraries. So if you're looking at accelerating any kind of math-based functions, we have dedicated investment of math libraries that is mapped onto our general-purpose machines like CPU, or also to our Hexagon engines. Here, you can look at taking any matrix-based operation or vector-based operation, and then you can get the highest performance that is mapped onto the intrinsics of a hardware. At the same time, for advanced developers who really want to program to metal, we have the flexibility of using the C, C++, Python as a programming model to really write binaries straight to the metal and not necessarily going through an SDK. Now, coming one step lower in terms of system software, often you're going to see in the computer industry is you're going to have a mix and match of discretes combined with integrated solutions. So as such, you need to make sure that the experience portfolio that you have across heterogeneous compute platforms is fully available, but as a foundational investment structure there, you need to have interfaces that's available that supports these discretes. So this is available as part of a system interface, and we also provide emulation support just in case you really want to understand if I have to emulate a performance in x86 and I want to transition this from a performance standpoint on ARM, is this doable? And that's completely available as part of a Qualcomm AI stack. And last but not the least is in terms of OS. As I mentioned before, Qualcomm has a very wide footprint in terms of edge devices that it supports, from mobile to compute to AR to VR and also to automotive. And as such, we really want to make sure we support developers across multiple OS. It could be Android, Linux, Ubuntu, QNX, Zephyr from a real-time OS standpoint, and also not to mention Windows. On the left-hand side of the stack is our tools portfolio. This is with the intention is to really make sure the time to market is fully addressed. At any point of time, you want to have debug flexibility or IDE flexibility of visualization that is completely available as part of a tools portfolio that we have. We'll go a little bit more details on how it actually looks in the next couple of slides. Now, Onyx Runtime. This year, we went one step forward, and working with Microsoft, we now have Onyx Runtime integrated as part of Qualcomm AI stack. This is again very critical for us, is because it kind of gives scale. You have connectivity from the cloud to the edge, and then any kind of developer who wants to have that extension in terms of familiarity, either with x86 platform or even ARM-based platform, this is fully doable using ORT. So this was launched at Build. We've had some demos running on it. I believe we also have Stable Diffusion running through ORT. If people are interested, please visit our booth where we have this running as well. Now, how does Onyx Runtime map into our existing stack? Now, as I mentioned before, when you look at a traditional model deployment onto our stack, historically, we have taken Qualcomm Neural Processing SDK, and then we map it onto our API called as QNN API or Qualcomm AI Engine Direct SDK, and we map onto the different IPs of interest. Either could be CPU, graphics, or even Hexagon. This is how we have kind of established on Surface Pro 9 devices, which is in commercialization. Worked out quite well, but we wanted to really make sure we could integrate Onyx Runtime as part of it. So this is how we morphed it. Now we have Onyx Runtime integrated as part of a stack, wherein you don't really have to go through the Snapdragon Neural Processing SDK or Qualcomm SDK, as I mentioned before. We can integrate this straight with Onyx Runtime. We have a backend extension provider called QNN EP, and as such, it gives you the same access and the flexibility of support so that if you want to have portability across silicon vendors, this is completely doable with no performance compromise. Now, as I mentioned before, we're also putting a lot more emphasis on tools, especially around debug, on Profiler, on IDE, and visualization, because we totally understand the fact is we want the developers to be completely independent. If they're really looking at scale and time to market, it's important that we provide the necessary infrastructure that they could start looking for model construction to model deployment completely independently. So we put a lot more investment. We have launched what we call as Qualcomm Studio to a certain set of beta developers. We're going to make that scale fully available in the next couple of months. This video will kind of showcase how visually it's going to look like, and we'd like to take some broad comments. Please let us know how things look like when it gets launched out. Perfect. So this is how a Qualcomm AI Studio is going to look like, and I would love to get some feedback, as I mentioned before. Please try it out and let us keep us posted to continue to make improvements on this stuff. Now let's shift our topic slightly a little bit, right? As I mentioned before, starting from my talk, we strongly believe at a Qualcomm perspective that inferencing stays closest to the data source. Now, there are always going to be scenarios wherein investment in edge compute is just not doable, only because you want to do something quite complex in nature, and as such, there has to be a dependency on the cloud. So we truly believe that hybrid AI is going to happen, and we have the necessary infrastructural foundational pieces available to really make it happen. And hybrid AI can come in many, many, many ways. You can have a student-teacher kind of relationship wherein you ask a certain query. It could be a text-based query, an image-based query, and if the edge doesn't have enough intelligence to give you a certain response, then it kind of pushes automatically to a cloud perspective. So we strongly believe this is needed, and the next couple of months, you're going to see a lot of interesting releases coming out that actually showcases how Qualcomm is actually prepared to drive towards hybrid AI. And last but not the least is what does the future of AI look like from a Qualcomm perspective? Now, there's always two extremes. My mom keeps asking me all the time is, are you working on AI to actually create a scenario like T2 or Terminator 2? I said, that's not the case. Machines are not taken over the world yet. So we are somewhere there, but not there yet. So I suspect, it's unwritten at this point of time. It has really morphed how people think. It's really pushed towards how productivity, content creation could be fully enhanced. So I think, it's quite broad in nature at this point of time. Qualcomm is strongly investing on-device AI with the expectation that we provide the necessary software and tools for the developers to really drive new use cases and applications. So I think at this point of time, it's looking great. And let's see how the future holds. So with that, thank you for providing me this opportunity to talk about Qualcomm AI Stack. And I'll be ready to take any questions at this point of time to audience here or online. I don't see anything popping out here. Oh, yes. OK, so let me read the question. I'm interested in Windows Studio's effect on a cell phone. Is this something that's possible today? Where do I find information? I think this is completely doable. This is part of Teams app offering. And my partner in crime, Fred, always pushes the fact that you need to have developer consistency and experiences between either a mobile device or a PC compute-based device. So I think this is completely doable. I think you download your Teams app. Most of these Windows Studio effects gets integrated and is made available, and you can get them fully functional. Any questions from the room? OK, thank you so much for coming in.